Hello everyone. So I'm Tristan. I'm the co-founder of Escape, and we are a company specialized in securing GraphQL APIs, and more specifically, public-facing GraphQL APIs. So first, let's know each other a bit better. I'm French, but I've lived in Argentina, in the US, and in Spain. I'm an engineer and an MBA. I've did research in machine learning applied to source code, and more specifically, source code analysis. So source code analysis, graph, abstract syntax tree, GraphQL, everything makes sense. I loved GraphQL as a developer, but I struggled to secure it. So I decided to create a company for solving that problem. So basically, Escape is the first fully automated GraphQL security testing tool. And we are the only company to have a security research team specifically on this topic. And this is part of the research that I will show today. But as well, we have like a free tool, which is GraphQL.security, a public tool, which is designed for quickly testing the security of any GraphQL endpoint. So I can do a quick demo of GraphQL.security in front of you. So it's very simple to use. You enter your endpoint, and you click and scan, and very quickly, we will scan the API and try to find security flows and best practices inside of it. So here, you can see that I have a few bad practices in terms of security on this API. So since this tool is free, it has been used by a lot of developers for scanning their endpoint. So first I will disclose what all those audits of security of GraphQL endpoints I told us about securing GraphQL, and more specifically about the best practices for securing GraphQL. What's interesting is we can fingerprint the engines that are used by the people, by the developers to create their endpoints. So as you can see, Apollo indeed has still some weight in the community, but in the recent month, and specifically last year, we have seen a lot of other engines appearing and getting more and more used. A bit of PHP, Python. There are also a lot of new engines in the Node.js ecosystem, which is pretty cool. So in those 1,000 endpoints, we found more than 5,869 alerts, security alerts in the endpoint. So that's a lot of security alerts. What were those endpoints vulnerable to? So first, more than 95% of those endpoints had HTTP misconfigurations, and more specifically, CSRF, cross-site request forgeries, which are a huge problem in GraphQL. More than 80% of them were vulnerable to denial of service, and I joined Lauren in his talk about that. GraphQL is very vulnerable to denial of service and complexity attacks, and we have seen that in the production endpoints. And about 20% of them were vulnerable to information disclosure from public-facing endpoints and without authentication. So you disclose information to the public. Let's start with the basic, how to secure these endpoints, how to improve the security of those endpoints. Let's secure the HTTP layer and avoid CSRFs. I will go fast on that, but it can look a bit boring, but it's still forgotten by a lot of developers on their endpoints. So activate STS, of course, to avoid using HTTP, enforce HTTPS. Enforce content type application JSON, because multi-part form data and application URL form encoded should not be used for GraphQL. And if your endpoint is not public, be sure that you set the access control allow origin header to avoid people doing cross-site request forgeries. And the second thing, which is specific to GraphQL, is never allow mutations using GET request. Because GET request should be, per HTTP standard, safe, idempotent, and cacheable. Whereas mutations in GraphQL are more akin to post or put request. So comparing with cookie authentication, it enables a browser, a user, while clicking on a link, to create a change in the database and make the equivalent of a post request, which is a very bad practice, and which creates a get paste CSRF. So avoid never allow mutations using get request. Now let's switch to the interesting part. Deeper into the graph, let's avoid abusive queries. So as that was said in the previous talk, GraphQL is a pretty complicated language. There are a lot of features inside. There are operations, fields, directives, parameters, aliases, batches, fragments, and so on. Well, basically, to stay secure, limits must be set for everything. Everything. First, we need to limit batching and aliasing. Batching is when you put multiple GraphQL queries in one HTTP request. And aliasing in when you put multiple times the same fields inside one single GraphQL queries. The problem with batching and aliasing is that it can be used to bypass the rate limiting if the rate limiting is done on the HTTP layer. So it can, if you have, like, for instance, a login mutation inside of your GraphQL endpoint, this can be used to do a brute force attack by sending one HTTP query that contains, for instance, 100 login trials with different users and different passwords. I'll give examples for Apollo, but it is very similar for other kinds of GraphQL engines, at least not JS-based. So basically, you can deactivate batching, and for deactivating aliasing, I don't advise to deactivate it, but rather to put a request, a limit on request complexity, which I will show after. Again, GraphQL can have arbitrary depth in the queries, and as it has been said before in the talks today, this can lead to denial of service if you go very deep inside of a GraphQL query and create resource-intensive operations. So we need to limit that as well. There is a handy package for that, for JS-based, but I will come back to that later. We also have a solution at Escape. The query complexity is like using both the depth and the width of the query to create, again, very resource-intensive queries. It can also be used to recover a lot of data from the GraphQL endpoint, and especially combined with a problem in access control, attacker or malicious personnel can leak a lot of sensitive data using that. So again, there is a GraphQL validation complexity plugin in order to solve that problem. Now let's avoid information disclosure in our APIs. So a lot of GraphQL endpoints have debug mode activated in production, and so they give the stack traces of the errors that are found. The problem with stack traces is that they give a lot of information on the inner working of your API. Specifically, you can see here there is like an example of a stack trace which gives the gateway, like the number, the version number of the Apollo gateway, which is used by this API. And if we take a look on the internet, we can see that there is a vulnerability that is well known for this specific version of this specific package. So when you disclose stack traces, you give a lot of information to attackers for them to know which precise part of your API are vulnerable. This is where the hackers start when they want to hack APIs. So you can generally put not env to production to enforce and not having that problem and not disclosing stack traces. An interesting fact about GraphQL and a lot of engines as well is that even endpoints with disabled introspection still leak the schema through field suggestion. So basically, field suggestion is when you type a field in a query with a typo, the engine is good with you and it will tell you back, okay, did you mean rather this type instead of what you type in your query? But the problem is this is still activated when the introspection is deactivated. So by using a smart fuzzing algorithm, you can build back the full introspection. So here I give an example of a full introspection we built back using the open source tool Clairvoyance against an API just by fuzzing the API and parsing the field suggestions. And in this specific case, the company that did that thought they were protected because they didn't disclose their schema, so they forgot to protect their update admin mutation. And we were able to change the password of their administrator. I'm not joking, this has really happened. So don't do security by obscurity. So as of December 2022, Apollo did not have an option for deactivating field suggestion. So a possible solution is to add a custom format error middleware that will strip the field suggestion from the response, so the malicious attackers don't have access to that information and cannot build back the schema. So let's do a quick summary of the best practices that I relived as of today. So start with the basic, secure the HTTP layer and CSRF, set strict transport security header, content type, and access control allow origin. Never allow mutations with GET request to avoid CSRFs. Avoid abusive queries. Limit query batching and aliasing, query depth, query complexity, and avoid information disclosure by disabling stack traces and debug mode in production. And if introspection is deactivated and you don't want the schema to be public, also deactivate field suggestion. We created a solution for implementing all those best practices for a JS-based GraphQL engine, which is GraphQL Armor. So this is an open source middleware that we created at Escape. And basically, you can install it in any JS-based or TypeScript-based GraphQL engine and implement in one line of code all those best practices in your API. But what if we want to avoid business logic flows? Because those are mostly configuration-based problems. But what if we want to test the business logic of our application? What about testing access control in GraphQL, which is by nature a graph and complicated to check the access control? So legacy API security testing with linear sequence of requests doesn't work for GraphQL. Because GraphQL is not linear, it's a graph. And we created at Escape an in-house new technical approach, which is deep graph security testing, and which will find the security flows very deep in the schema and test all the resolvers, even the deeply nested one, in a completely automated manner. So first we identify the sensitive part of the schema, and then we will explore all the paths dynamically in the schema to find and test every deep resolver leading to sensitive data. So we'll enumerate and test all the paths. While testing all the paths, we get a lot of information about your API, and more specifically about the data that is exchanged in the GraphQL API. So we can generate precise test cases that have relevant data according to the business logic of the application and that can pass the validation layer in order to test the code of the resolver itself for vulnerabilities. So what have we found using that approach at Escape? Passwords. We have found GWT tokens. We have found GCP tokens in a banking app. We have found AWS keys, personal identifiable information, SQL and NoSQL injections, MongoDB, very bad, database enumerations, of course, and fragment recursion denial of service. So basically, we created requests with recursion in fragments, and these have been mentioned before, and that's just put a denial of service on the API. So we decided to improve this algorithm and make it so quick, so fast to run, so that it could be integrated into the CI/CD. So basically, now it's possible to start testing the security of your GraphQL endpoint inside of the CI/CD directly in order to ensure that each new release does not have data leaks, that does not have bad practices from a security point of view, and is compliant with the best security standard. So you can test it for free. You can just go on Escape, and in 5 or even 2 minutes, you will have your first security report on your GraphQL endpoint if it's exposed to the internet, and we'd be happy to guide you through that later. That was all for my talk. Thanks for your attention, and I would love to answer your questions. Yep. Of course, yeah, yeah. Yeah, there was a question?
Yes, about the security part and about the gateways. Do you know right now the API management tools?
Yeah. So the API management tools are quite late to security from my point of view. I think in the future they will handle some of the security stuff, and I think mostly about the best practices themselves. But for testing the business logic, the API management tool don't really know what should be the access control for real. So this is like different, like testing the resolvers.